way to determine acids and bases is to actually go through the theories like we did in class. Start off with the easier one, which is the Arrhenius acids and bases, progress through Bronsted-Lowry, and then end with Lewis. Anything left is probably a neutral salt, and then we'll talk about what it means to be amphoteric. The first thing that I would acknowledge is the fact that this is a flow chart. It's a lot of if-then statements. So we'll start with an important one. The first question I would ask is, does the formula start with H? If the answer is yes, then this is an acid. If the answer to that question is no, I would ask the next question. Does the formula end with OH? If the answer is yes, that's going to be a base, except if you have vinegar, which is CH3COOH. This is an acid, and that's called vinegar. You'll just want to know that one. That's an organic acid. The next question I would ask myself, if the answer is no, is I'm going to look for a Bronsted-Lowry base. So I'm going to ask myself, is it an ionic compound with a polyatomic anion? An anion is the negative part of the formula. If the answer is yes, I'm going to call that a Bronsted-Lowry base. If the answer to that question is no, I'm going to check and see if it's a Lewis base. The question I would ask is it a covalent compound with a lone pair on the central atom? That means dots that aren't bonded to anything. Remember, those are going to show up in the nitrogen column and the oxygen column mostly. If the answer to that is yes, there's a lone pair of dots. That can act as a Lewis base. If the answer is no to that, it's probably a neutral salt. You're going to look for things like sodium chloride, NaCl. That's a neutral salt. Anything like iron chloride, those kind of things are going to be neutral salts. So let's see if we can just go through our list. If we look at the first one, NaOH, does the formula start with H? The answer is no. Then you'd ask yourself, does the formula end with OH? The answer is yes. So this would be called a Arrhenius base. The next one, NaHCO3, we would go through our list. It doesn't start with H. It doesn't end with OH. So my next question, is it an ionic compound with a polyatomic anion? And the answer to that is yes. If I look at this compound, you're going to find that it's an ionic compound because it starts with a metal, and the polyatomic ion is hydrogen carbonate. So for this one, it's a Bronsted-Lowry base. The next one that we'll do is HCl. The first question that we ask ourselves is, does it start with H? And the answer is yes. This would be an acid. The next one is water. And as you look at it, once again, it does start with H. So water will act as an acid. However, you need to be familiar with water. Water also acts as a Lewis base because it's a covalent compound with a lone pair on the central atom. So H2O is what we call amphoteric. Amphoteric meaning it can be both an acid and a base. Let's go to NH3. NH3, does it start with H? No. Does it end with OH? No. Is it an ionic compound? No. Then we're going to ask ourselves, is it a covalent compound with a lone pair on the central atom? If you do the structure of NH3, you will find that nitrogen has a lone pair of electrons. NH3 would be called a Lewis base. The last one that we'll deal with is NaCl. NaCl does not start with H, does not end with OH. It is an ionic compound, but it doesn't have a polyatomic ion. The next question, is it a covalent compound? The answer would be no. So this one, if you go through the entire process, NaCl is a neutral salt. That's a very quick overview. Hopefully that helps.